Good evening, everyone. Welcome to the 28th episode of ICC Biz Live, our knowledge show with, CEOs. Today, we have a very interesting topic, agentic AI, and we will take a deep dive into it. But before we begin everything, we request for an introduction of Sanachit Mehra, co-founder, Cateina Technologies, a very reputed company, and real. Mr. Mayor, I request to introduce yourself and your company.
Thanks, Rajeshi, and thanks a lot for having me here. As far as intros are concerned, I am with Mirza Ghalib on this. वो पूछते हैं गालिब कौन है तो तुम ही बताओ कि हम बतलाए क्या. As far as my background is concerned, I've spent more than a decade, building banking backends. I've built everything from blockchain systems to API banking. And for the last couple of years, I've been my company, we've been focusing heavily on AI. So I'm an IT grad. So like I said, the last 10, 12 odd years, this is pretty much what we've been doing. And as far as the core expertise is concerned, I guess my focus is just ensuring that somehow we are able to remove the pain that's inherent in a lot of financial processes. So yes, that's the basic philosophy that I use in all the systems that I build every day, and that's precisely what I intend to do as far as these agentic flows are concerned. In fact, it's all the rage these days. Everybody's trying to replace everything out there with AI, but I think there's a human and ethical angle involved to it as well. Maybe we'll cover it later.
Now, before we go into the topic of the day, can you explain? This is from the Aam Aadmi. AI algorithms, large language models, big data analytics. How do they integrate all together?
So I think it's important to take a very high level view of where things are and then attack things from there. See, AI itself, it's an emergent phenomena, which means that it's not fundamental. It itself is built on top of some things which are more core and fundamental to it, which is precisely where big data comes in. Data is atomic. Data is going to be the keystone, cornerstone for everything else that you end up building. So yeah, so big data is literally just that. It is data which is big. By big, it could be terabytes, petabytes. Depends on how you want to look at it. So it comes with its own inherent problems. How do you store it at scale? How do you cleanse it at scale? How do you manage it at scale? How do you handle errors, reconciliation, etc.? So that's a completely different field altogether. But what you can do with that big data is something remarkable. And that's where this sort of overarching umbrella of AI comes in. AI or artificial intelligence is effectively this umbrella term that we give to anything that shows even some decent manner of automation. Doesn't even have to be autonomous, by the way. Any degree of automation. In fact, uh, this is a regular ongoing joke in startup circles that if you want to be a unicorn, the first thing that you have to do is just label yourself as agentic or an AI-based startup, and all you need to do is maybe have an if-else loop somewhere. So that if-else condition is also some kind of an AI itself because it's a system taking decisions, although those decisions are rule-based, and that's where it's super important to segregate this umbrella term of AI into its constituents. You're going to have these rule-based systems, which can be expert-based or not, and these more emergent, newer solutions, which are more Gen AI based. So these are your agentic systems. So I'd say if you want to think about it, at the very bottom it's always going to be the big data, and you're going to use this big data to train your algorithms, which can be either in the rule-based category or they can be in the emergent Gen AI-based category. And they all sort of come under the overarching umbrella of AI. So all your machine learning algorithms, all your GPTs of the world, they all are a form of AI or the other. So if it helps, yeah, that's the heuristic I'd take to think about it.
Understood, because I
Yeah.
have studied this subject. Thank you. Now, before we go into agentic AI, one question on generative AI, Chat GPT versus DeepSeek AI. If there's a huge argument, Chat GPT has become increasingly popular from the student to the executive. But DeepSeek AI, they say, is much more of utility because it uses less energy, less data, less time. What is your opinion on these ChatGPT versus DeepSeek AI? Is
Um,
DeepSeek that popular? That popular?
uh, DeepSeek is popular. It is fairly popular. It's I would say one of the most popular LLMs out there. It's also one of the more it's one of the more popular open source LLMs out there as well. And that's the crux of it as well. So if you look at GPT, uh, these models are all closed source. In fact, they stopped open sourcing their models a fair while back. It's been quite a few years since they open sourced their last model. And we've heard from OpenAI that they're going to open source GPTs very soon. But it's been a couple of years since they've been talking about it, so I'm not holding out any hope there. As far as the efficiency of a model is concerned, I would say that the popularity of a model is seldom a good measure of how good it actually is. Uh, um, it's and that's where things sort of start getting colored in a certain fashion as well. I mean, if you look at DeepSeek, the good thing is it's open source, it's freely available. If you want, you can tweak its weights as well, which means that you can retrain it. This model, you can uh, make it work for your own specialized, specific purposes as well, which is great. If you want, you can host it in your own data centers as well. So if you are in a regime which talks about data localization, then DeepSeek is great. You don't have to worry about anything. Uh, OpenAI's GPT, I mean, it would be limited by the data centers which it offers from its cloud-based plan. So that's what's going to be limiting about it. Having said that, I've again, this is highly subjective. I've used both, and I find that it's always got more to do again. And this is purely from the perspective of somebody who's going to consume these LLMs. I found that it's always going to be more about how you sort of structure your queries, which lets you come up with a decent enough, a reasonable enough answer to your questions than anything else. Beyond that, GPT is not just an LLM, it's also agentic, which means it also carries a memory of all the questions that you've asked in the past as well. And it's sort of these days it's also able to execute a lot of tools out of the box for you. So it's available, it's maintained, it's available for a commercial purpose as well. So I find that it's probably a bit more polished than DeepSeek. But again, hats off to the DeepSeek team as well. They've been able to build, manage, train an LLM with a fraction of the data that it took OpenAI to do it. So yeah, they're definitely doing something way better on that front.
Sir, I am getting from you is structure your query, use both, and then apply your own mind as to the utility of the answer. That is what I am getting. Use your own brain
That's it.
as well as the answer these two systems gave. Very nice, very nice. Now, today's topic is from APIs to autonomous agents. Describes the evolution of AI and software development, moving from a model where systems require specific pre-programmed instructions to one where intelligent, goal-oriented entities operate and make decisions independently. Am I correct? But I'm not asking you to explain it right now, or uh, we would go step by step. But tell me, am I correct in as far as the definition is concerned?
First things first, I pride myself on being a good enough parser, but इतना जल्दी बोलोगे तो मेरे को भी समझ नहीं आएगा. Having said that, I think the question here is uh, uh, about the evolution from rule-based systems to agentic and more autonomous systems. And I think I mentioned this earlier as well. And this is how the progression of software dev has happened too. I mean, if you look at how we used to code earlier, and this has always been the case. We've always sort of had a process-based view of creating something. So, and maybe this takes a maybe we should take a while explaining this, right? So let's say you are hungry and you would really want to have, I don't know, okay, I'm hungry. I want to have a pizza. So you're hungry and you really want to have a triple cheese pizza. So what do? There are two options available to you. The first option is to just tell somebody that you need a triple cheese pizza and be done with it. Okay, which means it's a highly goal-oriented process, and it works. I mean, if you find the right expert who knows what the end expected state you are asking for is, you would very soon get a reasonable enough output as well. So I could just call a chef, I could go to a restaurant, place an order, they'd give me something. That's one way of doing it. The traditional way of doing our programming has been to sort of work with the recipe, which means that if I want a triple cheese pizza, instead of just telling somebody that I want a pizza, I would first, knead the dough into a ball, wait for it to ferment, plaster it with a lot of olive oil, uh, apply my toppings, let it bake for a while, and let it come back to me, half cooked, half baked. Test it. If it's uncooked, bake it again for a while, and after a while, it's probably ready. So that's the traditional way where you know what you want, but instead of just throwing that end goal at something, you follow the entire process of going through building it. And that's where I guess these newer systems are so powerful. They give you this ability to build expert systems at a fraction of the time and cost that it would take you to do traditionally. So traditionally, if I had to build, let's say a code base which was 10,000 LOCs, it would probably take me a decent week or month or whatever. But with LLMs or agents, all you need to do is again structure your query well, give it a decent plan of what you need, tell it the criteria of success as well, and that's critical. Tell it what your criteria of success are, and boom, you have very soon a code base which, if not 100% of what you want, is at least very close to where you want it to be as well. And that's the difference. Instead of building everything from scratch and following the recipe all the way, we now have the ability to just find the right chef for the job and just throw the expected end state at them. And I guess that's the powerful thing that we've seen with the evolution of Gen AI.
Okay, understood. Now, next question is what are, I mean, in the following in the same track, what are agentic systems and what are reactive systems? How do they differ?
So this is very, I'd say, related to what I just said, right?
Yeah, it
And
is related to what you just said.
it's very related. And in fact, this is the right time or maybe the right example to sort of delve deeper into it as well. So a reactive system is literally just that. It reacts to what you do or what you ask. So a typical system or a typical reactive system would have no memory. It would expect an input and it would throw back an output at you. There would be no self-correction, there would be no remediation, there would be no feedback loops. Agents are different. I mean, it's not just LLMs. An agent is not just an LLM, of course, it's an LLM with a pre-programmed prompt, yes, but it also carries memory, and memories are important. I mean, we always say that memories are what make us human, uh, and that's very true of agents as well. Your agent can, in fact, learn from its past mistakes. Your agent can learn from your past questions, your past interactions as well. And so an agent is completely different from a reactive system because it has that memory. It knows the context. So if I ask for a pizza today and I ask for, let's say if I ask for a pizza and I ask it to, let's say, keep it free of pepperoni, and the next day I ask for a calzone, the agent would know that I do not prefer a certain variety of topping on my snack. And again, if it was smart enough, it could actually say that given your past orders, I know that you don't like this topping, and so this new snack that I'm going to prepare, I'm going to keep it free of this topping. Do you want me to continue or not? And that's so important. A typical reactive system would look at your query in isolation. It would not worry about the larger context because it's stateless. It doesn't know about the past interactions that you've had. And again, so one good example of this is, your typical math class. If you are a standard one, standard two child, every day you go to class, it feels like the first day you are attending your math class as well. Your And that's the way a reactive system works. At least it used to work with me. But an agentic system is like a PhD. They know precisely everything that's been going on, and they know how to structure a response on the basis of everything that they've learned in the past and every interaction they've had with you. So think of yourself as the instructor of this sort of PhD student, and that's what's important, because you would have a regular interaction with them. The agent would then keep improving itself, and if you want, you can have a huge series of agents connected to each other. So this graph of agents would have some agents which would structure a response, and then you would have downstream agents which would check the correctness of the response, and then feedback would go upstream from these agents so that the first agents can then correct their responses and then send you back a new reply as well. So these are self-correcting systems. These are autonomous. They learn, and therefore completely different from your typical reactionary systems as well.
So my next question you have answered almost. My next question was, for an agentic system, what are goals, plans, actions, and feedback? You have answered the goal part, but the plans, actions, and feedback. Plans. Do you set the plan by or and plans, actions, and feedback, and what a state and memory part also you answered. Well, how how does an agentic system plan, act, and get the feedback? Plan, action, and feedback.
So I think, again, so the best way I find to
You
reason
have given the
about
goal.
agent.
Now how do I? You have given the goal. Now how does the system plan, act, and get feedback?
Yep. So again, so the way I want, again, I think it helps if you think about agentic systems like, the way you would learn or the way you would act in real life, right? So anytime you have to do something, what's the first thing that you do? Uh, I mean, you think about it. You have a goal in mind, right? Like in my case, let's say if I wanted a triple cheese pizza, the goal was to get a triple cheese pizza. So you set a goal. And the goal, and here's the beautiful thing, goals can either be given to agents by human actors or by agents to agents as well, and that's the important bit. In this entire heuristic, we can always replace actors, whether human, with robots. So a goal can be set by any consumer of the services offered by the agent. So if the agent is, let's say, a review writing agent, then the goal for this agent would be to write let's say, a scathing review of a movie, for instance. But which movie to select for this review could be driven by either a human or by another agent. Let's say again a recommender service for a user. So if it's Netflix, that's using this entire value chain of agents, they might have a recommender service which is backed by agents which recommend movies, and these recommender agents take those recommended movies to a downstream agent which is a reviewer agent, and all of this chain is agents talking to agents then instead of humans asking for you. So that's your goals. Beyond the goals is the plans. You have a goal, you want to follow a recipe to come up with an outcome. And that's where the agent's system prompt comes in. So if you are a reviewer and you know you've been asked to write a review, you know what you have to do, all the critical steps required to write that review. And so that's the system prompt which would be inherent to a specialized agent. Of course, these prompts can be appended, they can be enriched, all of this can happen while building the context. But once all of that plan has happened, has taken place, after the planning comes the actual actions, and that's where the agents kick in. So the agent may decide whether they want more information. So for more information, they want to get more context from a database, or they want to ping a URL, or they want to execute a tool. So that's an action, and the outcome could then be evaluated by a downstream agent. So let's say I have a reviewer, but I also have an editor, and the entire purpose of this editor or a copywriter or whatever is to review or the work done by the reviewer itself, and they may find additional faults, and that's the feedback thing. And it's like any typical learning system. You have teachers, you have students are assigned tasks by teachers, students perform their work, and students may or may not be correct, but the books are typically evaluated by TAs, and the TAs grade them and tell them what to do better next time, and students over a period of time hopefully end up improving. So that's goals, plans, and feedback. The important thing is that the feedback ends up becoming another prompt which gets appended to an agent's query. So the agent looks at the incoming prompt and the feedback as an additional prompt, and looks at the entire context within which it has to solve a problem. So now it has everything, and therefore it can do its job better. So that's how those things sort of work together.
Understood. And the feedback gets embedded into the memory. I understand that. Now, you compared with students' performance is judged by marks. What are the metrics for agent performance and reliability?
So here's the thing. We have agents, and we just mentioned that these agents, or the way these agents behave, is very similar to how our thinking or doing process works. You have your goal setting, then you have your planning, then you have your doing, and then you have your feedback. So, which means that if we have to measure the effectiveness of um, any agentic system, it has to be on the basis of these four core pillars out there. So as far as let's say goals are concerned, I'd say a good metric for uh, uh, an agent would be goal achievement. So if I, let's say, wanted a review to be written, how close was this agent to achieving this goal? And then there comes the planning. So for planning, it's more about applying your brains. And the question then becomes, how autonomous was this agent really in coming up with plans? Because was this agent able to do it on its own in a single shot, or did it require additional prompts from users or other entities to make this work? So the level of automation or autonomousness is also one. Then comes your action. So within actions, it's important to measure, how effective or efficient this agentic system was in terms of performing its tasks. So tasks take time because tasks are assigned to tools. So a task could be, let's say, writing a review or doing a deep search over a website by scraping data, or it could be executing an API or writing a code base or triggering a build or a deployment. And all of these tasks take time. And we need to check how efficient our agents are at executing these tasks. And executing these tasks without errors is important. And that's very highly linked to the feedback metric as well, which means that if I am able to execute a task, was this task free from errors? If not, what was the percentage of errors involved? And finally, we want to ensure that these systems improve over a period of time, because that's what you're saying. These agents have memory. So if they have memory, they should be able to improve over time, which means that we need to measure the effectiveness of feedback as well. So once you have customer satisfaction coming in or user satisfaction scores coming in, along with the error rates dropping, you now know how efficiently these agentic systems were able to manage feedback as well. So I would say between those four odd pillars of building your agentic reasoning, you also have your sort of four or five odd major metrics that you want to keep track of. Beyond this, I would also take a strict look at the number of tokens used as well, because these things can get very expensive very quickly, and you don't want to have systems which are getting stuck into feedback loops as well. So there has to be a jailbreak system wherever, and if your agents are going completely out of whack, then it probably always helps to ground them in knowledge, and that's where instead of having any random tools coming in, we want to have, let's say, internal knowledge bases or RAG flows coming in and saving the day for your agents. But yeah, I guess these four or five odd metrics are crucial for agentic reasoning systems.
Do you build an agentic? Have you built an agentic workflow yourself?
Yes, and I guess that's probably a good time for me to show off. I think we have some slides prepared as well for this, and maybe this is a good time for us to see some actual agentic systems in action too. So if we can just quickly go over.
It is not this. You have shown the wrong slide, Mr. Soumya. Soumya, the slide. Oh yeah, sure.
Okay, let's just skip over a couple of slides. Yep, let's just keep going forward. It's probably going at the fag end of this. Yeah. Next, please. Next. 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 Yeah. I think this is good.
Okay,
So
sure. Explain.
So this is an actual agentic system that we ended up building for a cloud-based hospitality startup. They're fairly large. They have operations all over India, and the idea was fairly simple. I mean, while they are a fairly large operations-oriented workforce, it's super difficult for them to keep track of every single booking. And since they have operations across India in homestays, they also have many property managers and property owners that need coordination as well. And then if you add to the mix that the fact that every single booking is probably a repeat booking as well, and you want to ensure that the customers get a tailor-made experience as a key differentiator for this company, then I guess a typical system becomes super inefficient very quickly. And so what we did for them was to build an agentic workforce of system of, let's say, of agents which were able to take reservations from the website or from other media, track those reservations with their CRMs, ensure full customer support through omni-channel streams like WhatsApp, for instance, and again use these omni-channel streams to also help these customers customize their stay as well. And obviously, we end up building a separate flow through agents altogether for property managers to manage these properties as well. So if you look at this architecture, so again, the platform is called Ragnar. It's our platform. The platform uses the gateway component, and then there is the agentic RAG component to it. So I already mentioned RAG. So these are knowledge bases, systems inherent to your companies or organizations, because LLMs only have data which is publicly available. But you want your agents to be able to answer queries on the basis of your own data. That's where we need RAG. So we've broken up this entire architecture into the gateway and the RAG component. And every single guest request goes through the query agent, and that's the first step of the process. The guest request could come from WhatsApp, which means that this system is available via APIs. The guest request could come from the guest portal or the mobile app or the website, which means that we want the agent to be available to answer queries from any of these systems. So it's available as APIs. The queries are immediately understood by the agent and routed to the appropriate flow. So let's say if I say that I want to book a stay for 2 days for 8 people, two of them are non-vegetarian, three of them are kids, and I want to book this in Candlein. What are the villas that you suggest, and what are the things that you want me to do? So this is a fairly heavy query, and if you think about it, if I ask all these things on a website, it will be a series of queries and page jumps that will have to happen. But we want this to be a free flowing experience through either voice or chat. And so this query agent is able to parse its entire query and route those requests to the appropriate agents at the backend as well. So we have multiple agents working in tandem, and some of these requests would end up hitting the backend systems as well, because we want to, let's say, see whether a certain villa or a certain apartment or a certain service apartment or a hotel has the required number of beds available or not. And for that, we want the request to flow back into the the CRMs, and that's where we have databases connected as tools. But it's also quite possible that this guest is a repeat guest, and they already had, let's say, they've had a great experience in the past, and we want to enrich this new query with the experiences that they've had in the past, and we want to take those experiences from our database where we already have the reviews, and that's where the vector DBs come in. So we take your data, transform those into vectors, and as soon as a user query comes in, we want to see which of these objects most closely matches to the question that's asked, which means that we take your question and we append contextual data to it to enrich the question. So we create a query, sort of a query bundle, so to speak. Once this query bundle is available, the agent can then decide whether to construct an answer right away, or whether this query has to be handled downstream by a new agent. And on top of all of that, we then have the auth guards, which means that we don't just want agents to just keep chatting with each other, because like I said, tokens can get very expensive very quickly. We want there to be guards in place. These guardrails will ensure that only authorized agents are able to execute certain actions. It's like in implementing role-based access control in an organization. So that's pretty much it.
Hello. I cannot hear you. Sanachit, I cannot hear you. ওকে শোনা যাচ্ছে না?
Okay. So I'm not entirely sure where I lost the plot, but okay, yeah. Uh, but as far as this system is concerned, it's effectively removed all the human actors from the process of booking, let's say, a vacation, and replaced all of those with agentic systems. And precisely where you would have a typical enterprise grade role-based access control or organizational hierarchy, we have replaced it with these sort of RBACs for service roles. And for every single role, there are specialized tools that they get to handle. And and you also have, let's say, the same exact hierarchies that you would follow in real life implemented in an agentic world. So let's say you have managers in real life, and these managers get to control what four subordinates do, and they get to coordinate and orchestrate the work that they do as well, and then come up with a response. And that's precisely what these agents do as well. So you would have, let's say, a manager agent, which would be responsible for orchestrating tasks assigned to multiples. So let's say we want to do a check-in, a remote check-in over WhatsApp. In this case, the task would be taken up by the query agent. It would go back to, let's say, a manager. The manager would recognize that for a check-in, there are three or four odd steps which have to be performed. There's, let's say, an identity check which has to be performed, a booking verification which has to be performed, and let's say a couple other things, to-dos as well. So now this manager decides which agents are responsible for which tasks. So instead of a single agent doing everything, this one agent coordinates the activities across multiples, eventually collating the results, and then comes back with the final pre-check-in. We were actually able to cut down a lot of ops work through this. In fact, most of the newer bookings that we've seen on the platform have been through the WhatsApp channel only, because again, super convenient and there are no human actors to deal with as well. Having said that, there are still provisions made for humans in the loop because agents are powerful, but they still need humans once in a while to help them along. Which means that if a manager agent gets stuck, it can always escalate a query back to a human to resolve as well. So there's a provision for that to happen. So yeah, I guess that's a fairly long discussion for an agent that we ended up implementing.
how do you does an agentic AI system integrate with the existing applications?
That's a that's a that's a good strong question because a typical answer to that would have been APIs. I mean, everything is APIs as well, and that's pretty much what I was going to say in the first place. But I mean, that's what we are saying, right? We are moving from APIs to agentic systems, which means that there has got to be a different way. These are not rule-based systems that we're talking about after all. And I guess that's where things like MCP servers or A2A protocols come in as well. So again, we can always have APIs, we can always have tools attached to LLMs or prompts, and all of this done one to one. But very quickly you find out that your applications, the code base size of your agentic applications goes out of whack. And so what you need is a way to quickly connect your tools with your prompts or your LLMs or your applications, and you need a standard way to do it. And so MCP is, in a way, that glue of the agentic world. So what you have effectively is it's a universal protocol for client and server applications to interact with each other. Uh, I'm not sure if this is a good explanation for lay people, but in a typical API-based architecture, what you would find is servers exposing API specifications of the resources they are exposing. It's basically saying that I
True,
am
true.
an application server. You want to consume my service. These are the resources I'm making available, and these are the methods that you have to follow to consume services, which means that it's very service driven. But it's quite possible, and it happens all the time, that servers have to communicate with clients for a lot of things. So for instance, I might ask you for a triple cheese pizza, but you want to ask me instead whether you want it to be sourdough or not, or whether you want it to be thin crust or not. And a typical server driven way does not let you answer those questions in an API spec. And that's where MCPs really shine. So an MCP server allows for the client and server side protocols to be defined very cleanly in the data protocol itself. And so it handles both sides of the equation, the requester and the provider. And therefore you have this sort of a very seamless way for both agents or agent human interactions to happen without any additional input going in. So yeah, for me, it's MCPs all the way.
So protocol matters. Now, before I go on to next question, I'd open the platform for any public question because we are running short of time. In the audience, anyone can question if you wish, and Mr. Mehra will answer. He's here with for another 10-15 minutes. So, okay, before any audience question comes, my next question is line graph. Can you explain line graph, what it is, what key features, capabilities, why is it that important?
Mm. So Landgraph, again, bit of background always helps, right? So it's about context, like I said. Landgraph is the natural progression of LangChain. So LangChain came before LangGraph, and LangChain was all about interacting with LLMs. So it gave you again a single canonical API to interact with any LLM that you wanted to handle prompts, any prompt that you wanted to handle documents, chunking, parsing, all those things. So these are all typical conventional things that you would do with your decoder models, so to speak. Um, but then very quickly we realized that we just don't want to build chatbots, and that's what used to happen a year or ago. There were a lot of chatbots, tons of chatbots, or at least sequential chatbots around. And we found out very quickly that they are great, but we want more autonomous systems. And to build these autonomous systems or agents, so to speak, you would need a framework. And LangGraph is precisely that. It's obviously the extension of LangChain, and it effectively ensures that the same ecosystem is now also extending into um, a, a, a graphic, not just a graph-based way of representing communications between these service roles. So that's what it does. So it lets you build agents, it lets you attach memory, it lets you work with state, it lets you work with prompts, it lets you work with feedback. Effectively, anything that you need to do to build a good, strong agentic system, you can do with LangGraph. Obviously, for feedback, you would want to have telemetry, you would want to have logs, you would want to have traces. And LangGraph has a fantastic ecosystem of open source and proprietary tooling available to get you telemetry as well. So, uh, so that's important. So as far as coding is concerned, and this is coding, it's a bit different from your traditional way of doing it, but this is still coding. We need to know how well our agents are performing, and so you would have either in proprietary systems you'd have something like Langsmith, and in the open source world you'd probably have something like a Langfuse that you would use to get traces from your systems to know how your agents are behaving. So LangGraph is not unique in that sense. It's one of the earliest frameworks out there to build um, an agentic system. It follows your uh, acyclic graphical way of doing it, but there are others as well. I mean, you could just as well build your agentic systems using I don't know, Llama Index. You could use Bedrock, AWS Bedrock. You could even use Google's ADK or Agent Development Kit. Uh, and there are tons of them out there. There's Crew AI, which I hear is fairly popular with developers out there. So yeah, as far as agentic frameworks are concerned, there are tons and tons of agentic frameworks. It's just like your languages. I have the ability to write my Node.js code or server either in Express or Nest.js or Fastify. It's a choice available to me. I decide what I'm comfortable using, but beyond that, it's got more to do with the tech than the framework itself. So LangGraph is fantastic. It's one of the earliest. It's pretty strong, but it's not the only one. That's important.
One question has come from the audience. You have a look at the box.
Okay. Okay, so how to increase social media engagement through API? Is there an easier way to incorporate? I I would love to answer this question. Unfortunately, मेरा खुद का social media engagement is pretty poor. Having said that, just like I talked about the agentic systems for booking hotel rooms or villas, you would have something similar here. Of course, this is sometimes governed by what's possible on a specific social media site as well. So, Instagram, for instance, has some restrictions on what a business account can and cannot do. So, it wouldn't, or let's say what a personal account can and cannot do, what WhatsApp can and cannot do. And so, we can have MCPs, but the MCPs would eventually be limited by what can be accomplished by a specific tool. So in an ideal world, we could have, let's say, an agentic social media marketing agent that understands your profile and your persona, and on the basis of your persona, it constructs a narrative or a series of posts that then lets you post on your preferred social media channel. And like I said, it could also take your previous interactions with the community in mind before constructing a new post as well. So it would, for instance, know that a reel of X seconds is with this sort of content is more popular than something with a different content or narrative altogether. So yeah, so your agents would do all of that. Uh, but like I said, it's also limited by what the platform if natively makes available to you as well. So if let's say a certain API is not available, you would probably have to go back to a more arcane or a slower way of doing it. So if let's say you have a private or a personal Instagram account and you don't have access to APIs, then the only way for you to post is to use a desktop or a screen control or or a headless screen control tool through one of these agents, and it's going to be very slow. It's probably going to use something like like Puppeteer, and scaling it up is also going to be challenging and very expensive. So yeah, some things can be done, but a lot of the times you'll find that these proprietary systems have paywalled ecosystems as well. And so getting behind those walled gardens is sometimes the bigger problem than just building the agent to solve your problem. I guess that I hope that answers the question.
One,
Rajesh, you're mute.
am I,
Yeah,
oh no,
you're audible.
I'm unmuted. Okay. Okay, give an overview of AutoGen. And another
So
question, next question is, when, as far as I did an economic analysis of AI implementation in India, and I found that AI itself is restricted to only the large scale industry. So, what is this when AI itself is deployed in large scale industry? So, what is the scope of agentic AI? I mean, in India.
so uh, see, there are different layers that you could attack, right? As far as AI itself is concerned, we could start building our own foundational models. I mean, that's the foundation of it, right? I mean, there's nothing stopping anybody from building their own DeepSeek, so to speak. DeepSeek itself ostensibly was built for a completely different purpose in mind. So yeah, so so it's not always going to be research labs that would want to build these foundation models. Sometimes it's also for profit as well, which is probably the best way to do it. So that's one, which means that for foundational models, we probably have to rely on research labs or maybe corporates or maybe financial services to pick up the buck, because what what LLMs can pick up very quickly is behavioral systems and languages and interactions, and that's very difficult. And again, probabilistically generate um outputs and outcomes from that, and that's very difficult to do otherwise. So that's one thing you could do with it. The second thing that you could do is use existing or pre-existing LLMs and fine tune them. So there are tons and tons of LLMs available on Hugging Face, for instance, and you could just decide that you want to, let's say, tweak an open source LLM for your own purpose. And this is something which has been tried and tested a lot. You would find applications of this, especially in the financial services space, where people have picked up LLMs specifically built for handling the financial services domain, or let's say tweaking LLMs to manage contracts and contract life cycles. So these are specialized LLMs which are not foundational models, but they are tweaks or foundational models. And I think there's a lot of play for that to happen because it doesn't require that much training as it would do to create your own LLM from scratch. B, again, the data is always available, and these days a lot of government and even private sector data is fairly well digitized, so you could do that. But on top of this, and I think that's where a lot of the market movement is as well, is in fact in building applications on top of these LLMs through agents, non-agents, chatbots, whatever you have it. Eventually, it's going to be, it's probably not going to be the number of use cases that you can handle, or it's probably going to be the experience that you're able to give. So again, those 4 5 odd metrics that I always talk about when it comes to dealing with agents. So can your agent really solve a human problem or remove a human from the equation? If it can, and if it can do it reasonably well, hopefully not without a lot of private equity involved, then yeah, I guess you have a winner at hands. And we've already seen a lot of Indian companies adopting agentic systems. I mean, very recently we had news of Zoho also, exposing its LLMs, especially in the Indian context as well. So there are plays, and I guess there will be more plays going forward, especially given the length and breadth of our country and the number of and the amount of diversity involved in our languages. So it's very difficult to build, a multilingual system. And so maybe India is in a prime position to do it for its own purposes rather than relying on third parties or foreign built LLMs. So that's something that we could do.
I think we are trying to do build our own LLMs to our AI foundation.
There is a national
Anyhow,
AI mission as well, by the way. Yeah, so you're
yeah,
right. Yeah,
that is funding building of our own LLMs.
yeah.
Yes. Anyhow, I think we are near the. If there are no more questions, then we are near the end of our session. 1 hour. Thank you, sir, and it was very useful, though a bit more technical. I understood. I understood, and the technical followers would understand very well. It was very interesting to hear you. Thank you, sir. And with this, would like to end the session.
Thanks for having me, Rajri. I just hope it was just as well as I thought it was. So yeah,
Yeah, it was good. It was good. Thank you.
thanks. Thanks a lot.